Appreciate you joining and learning more about Serverless Framework v3, which got recently launched about a week ago, and hopefully you've had an opportunity to try it out. We're gonna. So, what are we going to cover in today's community call? Obviously, v3. Matthew, our product manager, is going to show off, what's new in the V3 release, as well as demo some of the key new functionality for those of you who haven't seen it yet. And then Gareth, our developer advocate, will also be showing off some additional features on how to enhance your serverless framework experience with our dashboard service. And then in the second half of this call, we've got a great guest, Chris Crabtree, one of the co-founders of a startup called Joot. And they're doing some really exciting things with serverless framework in conjunction with DynamoDB and AWS's SageMaker service, as well as Python to use machine learning for image processing and helping agencies and companies decide the best images for their social media and for ads. So I think it's a really interesting solution that they've developed, and especially on serverless framework. So throughout today's call, we encourage you to ask questions in the questions tab, which should appear on the right side. And if you want to just say hi in the chat window, send us a message and tell us where you're calling in from. Sorry, not calling in from, where you're joining us from. So I'm on the West Coast of the U.S. Love to see, where our audience is and where everyone's coming from. So yeah, send us a message in the chat. So before I hand it off to Matthew, a couple of things. We've started expanding our guest author program and our community contribution program. So you might have noticed that on our blog a couple of weeks ago, Frederic contributed a guest blog post on serverless scheduling. And then we've been joined by Chris, obviously, to share their stories. So, if you are interested in sharing your story on how you're using serverless in a community call, or you want to write a guest article or a guest blog post, feel free to reach out to us. And I'm going to put a link here in the call to action that has a form that you can fill out. Sorry. All right. So there's a link to if you want to share your story with us. All participants will get a follow-up email after today's call that will also have this link, as well as other links and resources that might be useful for you as well. So this call is being recorded, and you will get a recording link as well. So there are also a couple of great resources. If you haven't seen them yet on our blog, we've got a couple of great articles. The first one is an overview of what's new in Serverless Framework v3, authored by Matthew. And then we've also got a great tutorial on how to get started with Serverless Framework, creating a web API, and having it backed by DynamoDB, and that was authored by Gareth. So not only do we have a tutorial article, but there's an accompanying video that you can follow along with, as well as a project on GitHub that you can copy locally to make it even easier. So I encourage you to check out those resources, and those are all on our blog as well. So actually, before we get into Joot, why don't I hand it over to Matthew to tell us what's new with Serverless Framework v3. And again, if you have any questions, please post it in the questions tab. So let me hand it over to Matthew. Hey, Matthew. I'm not sure we can hear you, Matthew. Maybe you have to unmute. Can you? Yep, I think you're on mute. Okay, Matthew cannot unmute. So technical difficulties. Give me just a moment here while we figure this one out. Okay, Matthew, I think is going to rejoin in just a moment. So let's just hold on for a moment.
Hello, hello. Is that working?
There you are.
I don't know why. I was clicking the mute button and it stayed mute. So let me pull the slides up. Sorry about that. Okay, I think that looks good. We can get started finally with Serverless Framework v3. So this is a quick overview of what the new release contains. So the Serverless version 3 was released last week, and we want to give you a bit of an overview. You can, of course, check out the blog post if you want more details, but let's get right into it. And I will be covering 3 main changes in the new major version. First one is a change in the CLI experience that we've redesigned, and I will cover that with some visual examples. A new feature called stage parameters. And finally, of course, breaking changes, because with this new major version, we have to talk about breaking changes. Now, before, if you are concerned with breaking changes, stay until the end, because you may be surprised to see that the upgrade is much easier than you might have expected. So let's jump into the CLI experience, the redesign. If you've used Serverless Framework before, you may recognize that screen very well. This is the output you get when you deploy an application with Serverless Framework. We started from that, the version 2, and what we wanted to do is try to improve that, simplify that, both for aesthetical reasons, but also to make that interface, that output, more useful and actionable. So we started with all the steps, the colors, the formatting, and this is what version 3 looks like. So on the left side, you have v2, on the right side, you have v3. As you can see, there is much, much less in the output, in the default output at least. The most important part where you deploy is you want to see that it succeeded. So hopefully here it's a bit more explicit. Success, like the deployment was a success. You can see the URL that you just deployed. So that's the kind of, situations where you deploy an HTTP application, and the first thing you want to do after deploying is either click that URL or paste it into Postman and play with it. That's why we wanted that output to be the most visible part. You can also see that we removed, I would say, noise or steps in the deployment. You only see the last step, which is a success. Still, when you deploy, you still get the details. What we've tried to do is make it a bit more interactive, where you can see what's happening, when it's happening, like packaging, uploading, CloudFormation deployment, and at the end, you get the success message. So you still get the details when you deploy, but in the end, the output is still pretty light. As you can see, we've played as well with interactive spinners in the CLI. One thing we also paid good attention to is moving up the information. So as you can see, the first thing that pops up is the name of the application you're deploying, the stage you're deploying to, like the environment, production, development, and then the region. Because we realized that even though we display that information at the end in version 2, displaying it first is a great way to prevent mistakes, where you start a deployment and it goes to the wrong region or the wrong stage, and you're deploying to production where you thought you were deploying to development. So here, it's the first thing that pops up. You can stop the deployment if you've made a mistake, and we believe it's really helpful on the daily, usage. Of course, that's the default output. Very minimal, but you can get more details with the verbose flag. The verbose flag has been applied to all commands in v3, so you can get very detailed information, and that's useful, for example, in CI/CD, where you want all the details. This is just some kind of screenshot of an extract of the deployment here with the verbose mode. As you can see, and if you've played with CloudFormation before, you know what this is. This is a log of all the steps your application goes through when it's deploying. For each resource, you can see the steps. And that's particularly helpful when you want to debug a problem with the deployment. So I'm not putting the whole output, of course, there because it's verbose. We've covered the success part, but also the failures. Because when it fails, you need to know that it fails, and you need to know why it failed. So we paid close attention to making it very obvious, is it the red thing and the cross, and you know something went wrong. And we reorganized the information as well. You see in the terminal, the last thing that is printed is the one that you see just above your prompt. So we've moved the error message just there. So this is the first thing that your eyes see. And with the colors, every secondary information is in gray and the main error message is in white. We've added as well information about the error, the cloud formation error, when that's an error caused in the deployment. So you can see the resource that failed and its specific status. Moving on to other commands, just a quick preview. Logs. This is some kind of secondary command, but it's used a lot, and it's very helpful to debug and develop even. And the thing is that the logs command streams logs from CloudWatch, and CloudWatch logs are a bit verbose. So what we've done in V3 is clean up information that could be noisy, like the request ID. We've simplified the start and report and end lines. And in the end, the goal was really make the logs command as useful as possible. So the main thing that you see here is the logs logged by the application in white. And in gray, you have all the secondary information. It fits in one screen in the terminal. That's much easier to use. And finally, the last screen I want to cover, or last command I want to cover, is the serverless command itself. No options, no arguments, just serverless. And that's a great way to get started and create a new project from scratch. You run that in any directory, one that doesn't have an application or one has an application, and it lets you choose what kind of project you want to create, how you name it. You can optionally onboard into the serverless dashboard to get monitoring. And you have the option to deploy at the end. So it's all an interactive command that you can run and have a very guided process to get started. Of course, we've covered many other commands. There are plenty of commands in Serverless Framework. I just wanted to give an overview of the main ones. And as you can see, like, the whole thing wasn't just about changing colors. It was really about making the whole experience more usable on a daily basis. So that was the CLI redesign. Now let's talk about that new feature, stage parameters. Stages or environments are things that when you deploy the same application to development, staging, and production. So that way you can test new features without breaking production. And many people follow that pattern. The thing is that sometimes you want to have different configuration between the environments. So in my very naive example here, I want to use a different domain name for maybe an API between production and the staging environment. And I could do that with different environment variables like here, but it's not really practical. And what we've seen most people do, and what we've done ourselves, is some kind of workaround with nested variables and the stage variable like this and the custom section. So if you recognize that pattern, we have something for you in V3. We've tried to make it much simpler with stage parameters. Basically, you define a new params section in serverless.yaml, and in there, for each stage, you can define values. The key is the param name, and the value is the value of the parameter, and then you can use that value anywhere, and it will resolve to the value that matches the current stage. So I can deploy in prod, staging, and get the right value in there. So it does bring a bit of simplification. Yes, you may be thinking this is not like groundbreaking. Yes, but this is so useful on a daily basis, and it simplifies so much configuration that we thought that was a really nice one to have here. So we hope you enjoy it. And finally, let's talk about breaking changes in V3. So over the last year, maybe more, in Serverless Framework, we've added deprecations, like change some features to improve them, make them more reliable, provide better alternatives that are less confusing or more powerful, but still, some things need to change. And yeah, as I said, there were some deprecations that were added. The thing is that when we planned V3, we realized that some deprecations were painful and would hurt the upgrade process. So we've tried to balance for each deprecation. Should we keep it? Should we make it a breaking change, or should we keep compatibility? And for some of them, we've kept compatibility. So that's about 80% of serverless framework projects today are ready to upgrade to V3. So if you've seen deprecations during the last year and you thought, oh, this will be a hard upgrade, you may want to reconsider that. So let me give you a few clear examples of what I mean by that. You may have seen that kind of deprecation where we change the way the applications are packaged to be deployed. Initially, you could do that with exclude and include patterns, and the new format is the one that you can see below with patterns. So old one, new one, and for V3, the idea was to switch and have everyone use the new approach. But many projects were still using the old approach, and we didn't want to make it so hard for all of these projects. So in V3, both approaches will continue to work. Now, of course, the recommended approach, the recommended way is the second one. If you start new projects, use the second way, but you can upgrade without having to change that. The same thing applies to IAM settings. You may be using these kinds of settings, I would say the old one, legacy one at the top. We've changed the way we define these settings by making them a bit more organized and with clearer names. That's an improvement. But yeah, again, so many projects use the old way, so we decided to keep compatibility and both approaches will still work. Use the new one in new projects and whenever you can, but you can still upgrade to V3 without changing that. There were a few other breaking changes that we revisited, like enabling strict configuration validation by default. This will no longer be the case in V3. By default, if you have validation problems, I would say, there will still be warnings by default, and you can manually opt in to have them turn into errors. Like if a property takes a value like between 10 and 100, and you put something that isn't compatible with that validation, you will get a warning, and it will still be the case in V3. Another one to mention with the deploy function, you can deploy just the one function and not the whole service with CloudFormation, which is much faster, by the way. But you have two ways of doing that. And the first one was actually deprecated because it was messing up. Like the deploy command is for deploying the whole project. Deploy function command is for deploying one function. And mixing the two was very confusing for users and also for the internals. So we wanted to move everyone to the second format, but people still use the first one. So we've kept compatibility and both approaches will still work. Sorry. Now, there are still breaking changes. These are just a few of them. Like Node 12 is now required. The CLI does not support Node 10 anymore, which is legacy version. So if you are still using Node 10, you should upgrade your Node version. There were some changes in the way the code is deployed to Lambda functions. And basically when we deploy the code, we have to calculate a hash to determine whether there were changes or not. The hashing mechanism has changed. So that's a breaking change in V3. We have written a whole guide that helps you with all breaking changes, but especially this one with commands to help you. So hopefully that migration should only take a few steps. Another one that you may be facing is freeform CLI options, where you put any option that you want in the CLI command. These are not supported anymore in V3. The good reason for that is that it prevented us to properly validate the options and help people see that they've made a typo or that they provided invalid options. So that won't work in V3 anymore. There are other breaking changes. They are all listed in the blog post. We have written a full V3 upgrade guide as well. You can find the link in the blog post. So hopefully upgrading will not be too hard. The nice thing, however, if you want to upgrade, is that we've based everything on deprecations. So what you want to do is first upgrade Serverless Framework to the latest V2 version. You run a deployment or any command, and if you don't see any deprecation, great, your project is ready for V3. If you see any deprecation, then you can fix this deprecation and then upgrade to V3. So if you have no deprecations, you're good. How to upgrade? If you're using npm to install serverless, this is how you can upgrade. If you have installed serverless as a standalone binary, there are instructions in the blog post that you can open with this link or this URL. And you can check out the blog post for more details on design features and upgrading. Not sure if there are any questions, but thank you for listening so far.
It looks like no questions yet. So again, if you have any questions, please post them in the questions tab. I think we have one request from, I think it's pronounced Veseline. I'm sorry if I pronounce it incorrectly. They're looking for more tutorials for Python with Lambda and AWS functions. Yeah, we'll definitely put it in the queue. If anyone else is doing a lot of work with Python and serverless framework, I would love to let us know in the comments. That would be interesting for us to know, and the scenarios that you're using them from. But unless there's any other questions about serverless framework v3, is there anything else that you wanted to chat about, Matthew, or should we hand it over to Gareth?
I'm good. So yeah, if there are no questions, we can move to the next one.
Okay. Gareth, you're up.
Thanks so much, Stephen. I'm going to grab the screen share from you there, Matthew. And it is that the right one? Yes, I think it is. Hello, everybody. I'm big on the screen now. Look at that. All right, there we go. Okay, great. So Stephen has alluded to this. We have there's a blog post I worked on, did a bit of work on, a tutorial to help folks who are getting started with serverless framework. And the reason I bring this up is that this also mentions something pretty useful with the serverless command. And Matthew also talked about the serverless command. It's really, I'm not going to go through the in-depth process of how to onboard with the dashboard. If you have an existing serverless framework service and you wanted to connect it to the dashboard, and you'll see why you want to in a minute, just run the serverless command and it'll basically walk you through the steps. It'll ask you if you want to log in or register an account and so on, and just follow right through for that. Yeah, and feel free to go take a look at the blog post. You know, if you know somebody who you've tried to talk into serverless, you can send it their way. There is the accompanying video embedded in it, so hopefully many folks will find this useful. All right, so I've been given 5 minutes to do something I often do a 30-minute demo on, so let's get going. So welcome to the dashboard. Once you've onboarded and registered an account with the dashboard and you've got some services deployed through that onboarding process, you might be wondering how the dashboard is useful to you. What can you use this thing for? And really, one of the problems the dashboard is trying to solve is that when we're building serverless applications, we either need somewhere central to help control some configuration settings, and Matthew mentioned the new params feature in V3, which helps a lot with that, and I'll be talking a bit about that further as well. But we also want to do monitoring of stuff. We want to see what's happening with the stuff we've deployed, especially once you're in production, because who knows what customers are seeing. You can go F5 your website as much as you like, but what are some of the other customers seeing? Are there any errors? Are there any problems? So once you've got a service deployed in this way, you're going to see your services waiting here for you to click on. So, for example, this is a sort of demo organization that I have set up in the dashboard for exactly these purposes. And I have an application here. I've added an app called Orders, and it has a service in it called Orders Gateway. That's what the service property in my serverless.yaml is. And the stage I've deployed is the dev stage in US East 1 region. But now I'd like to see some more information about the service I've deployed. So I'm just going to click right through to it. And immediately I've got a ton of information that I can work with here. First of all, I can see I've got API requests that happen. So there's obviously some kind of HTTP API attached to this in some way, and it's obviously experiencing some errors, which is something I need to take a look at as a developer. I don't want production to have to suffer these errors. Scrolling through here, I can immediately see which functions are affected, endpoints are affected, what my cold starts to look like. But let's hop straight to these errors that I might want to take a deeper look at. So the easy way to do this is just to click through one of these bars here. So I'm just going to click through to that. It's going to bring me to the Explorer page, which gives me a list of all the invocations, my Lambda functions that had an invocation that errored out during that time frame that I clicked on the bar for. And you can see I've already got here's my errors, name error. So let's take a look deeper. I can click through to any one of these to find out more information. All right. And now we have even more detailed information. We're filtering further down. We're taking a good deep look at what might be causing our problems. And as I go through, I can see my invocation errored out with a fatal error. Name SES is not defined. Okay, so that's given me some information to debug this. But if I just keep going down, I can immediately come through to a stack trace. And this is where my debugging really comes to the fore. The dashboard has told me that I have an error in my handler.py file at line 22 where I'm using ses.sendEmail, and obviously SES is not defined. I probably haven't instantiated the AWS SDK to create the SES object. I'm a dummy. So now I can go fix that and redeploy, and those errors will go away. And in addition to that, if I happen to console log some data out from my code, it would also be presented here because these are the CloudWatch logs directly from my AWS account, as well as the detailed errors that are pushed through to the CloudWatch logs so that I can get all the detail I need that would be pushed through to those CloudWatch logs. And you might be wondering, this sounds like a lot of stuff to have to fiddle and configure and set up. Unfortunately, once you've hit the serverless command and gone through that onboarding process, you deploy through to the dashboard, that's it. There's nothing else to configure. This is all automatically set up for you. You don't have to actually go and add anything in addition. This automatically starts acting like this for you and starts helping you trace errors, logging them, managing them, no additional configuration added. Where this is also powerful is that we have a fantastic feature called tags. And because we don't actually at the moment store your CloudWatch logs, it makes it difficult for us to let you search through the text of logs. But what if you wanted to search through data that's only generated at runtime? So in my code, I might be dealing with a specific customer record from my database, and some error happens, and I'd like to find all errors related to this customer ID. Well, with the serverless SDK that's also automatically bundled within my code, I can send runtime data to the dashboard. And we have example code or the documentation for this SDK available where I can use the tag event to go and send myself some customer ID data or whatever data I want at runtime to help me debug this application. Really useful if you also want to just filter through customer-specific or runtime-specific data. Very, very handy to have. All right. So all of this is really useful, but there's a bit more that we can take a look at. So let's go ahead and do that. I want to take a look at this form submit function here, because what this provides me is another great feature that's, again, automatically baked in that you do nothing to set up for, is spans. And you can see here, spans is a really useful way to help you determine what is happening with the timings inside of your Lambda functions. So I can immediately see that in my Lambda function, I called the create topic SDK call for SNS. I had a delete topic SNS call for, to AWS. I even had a GET request to a URL of some kind. I then stored an item in the DynamoDB, and I've got the timings for all of these. I can immediately see how any of the AWS SDK calls and HTTP requests are affecting the execution of my Lambda function, with a great little graph here as well. So this is really useful information, especially when you're debugging, because if it fails anywhere between here, you'll not see, if create topic failed, I wouldn't see these. And that immediately gives me an indication that something broke at that point, and I know where to go looking. So again, automatically generated, automatically monitored for you, nothing that you've had to work to provide to you. So in addition, there's another way I can help filter with functions. I want to now look at my functions in some more detail. So one of the things I would like to do is, for example, duration is a really important metric when you're dealing with Lambda functions, because that directly affects the cost of your Lambda functions. So one of the advantages you've got is coming through to the function section here for a specific function. I can switch between them. I can immediately see what my duration looks like. And if you run a deploy, you'd have an event line running through your graph to show you this is where your deployment happened. And you can immediately compare pre and post your deployment, what your duration suddenly looked like, and fix those. Same with memory, same with errors. And if you have an API connected, you get a very handy call request that you can use against that Lambda function to run tests. Last thing I want to mention, I've been given the 2-minute warning, is the parameters feature. Matthew mentioned parameters, and it's a fantastic feature in V3 because parameters is a way for you to store configuration for your stages. But what if you wanted a way to store them centrally for your shared stages, like your development environment, your staging environment, and so on? Params for V3 is fantastic if you do not need that centralized storage, or if you want a local developer to have some way to store those configuration values for when they're deploying into their own AWS account. But when you're deploying to dev and prod, you may want a centralized way to store them. And you can do that using parameters in the dashboard. By going to the settings for the service orders gateway, I can set parameters at the service level right at the top. But at a stage level, I can go through to my dev stage and override these specific parameters with a dev-only value, so that only the dev environment has this value for this specific parameter. And as the blog post, as the docs mention, these are encrypted in the back end, so they're completely kept secret and safe. They're only decrypted at deployment time when you need them. And if I have one last second, we have providers, which is the last nice centralized feature that lets you control things, is connections to AWS. So you can create connections to AWS at the organization level and then consume them at the service level. So the specific stage will use a specific provider and prod can use a different provider. And you don't need to worry about storing plain text credentials to AWS on somebody's local machine somewhere when you're making deployments or in CI/CD systems. So a very useful way to manage those. And I will now be quiet, Stephen.
Thanks, Gareth. Well, so, I think really that's obviously that's just the tip of the iceberg as to what the dashboard offers. So, there is a free tier for it. If you haven't explored it, I really highly suggest checking it out. As Gareth mentioned, it auto instruments a lot of the functionality that's already in Serverless Framework. So go to our blog, check out Gareth's tutorial, and it'll show you just how easy it is to connect dashboard to your Serverless Framework app. Cool. So thanks, Gareth. Unless there are any questions, please pop in with questions if you have them about the dashboard for Gareth, or else we will keep moving along and get to Chris and talk about his experience with Serverless Framework and how they built their servers Joot around it. Okay, so why don't we go over to Chris and let him take over and let him tell his story about Joot as well. Again, if you have any questions for Chris, please put them in the questions or in the chat, and then we'll stop periodically and answer your questions. So let me hand it over to Chris.
Great. Thank you very much, Stephen. It's great to be here. So my name is Chris Crabtree. I'm the co-founder of a company here in Utah, in the United States, called Joot. And you might be wondering, how did we come up with that name? And so I have this kind of little quote here that I've put up, which was something that was quoted on our website. And we discovered this term called Jootsing after we named the company. So this wasn't something we'd found first and then named the company. We thought it just was interesting how it coincided with what it was that we did as a company. This idea of jumping outside of the system was really intriguing to us. That's what we were trying to do with what we were trying to design. But also, when I think of it from the perspective of us using serverless to design and architect our technology stack from the beginning, was literally jumping outside of what is the typical system for doing that. So let me just move forward and tell you a little bit about more that what Joot does, why we decided to build and design it like we did, but what was the story around what kind of problems does Joot attempt to solve, and why did we use serverless to try to attempt to solve those things. So in August 2020, I started this company with a former partner of mine. I had started a company back in 2007 called Mozenda, which was a platform designed for doing web data harvesting. So data extraction, unstructured data, structuring that data, and then providing it in a useful way or an intelligent way for our clients to be able to consume through APIs. And part of that project, near, I think, the 2000 or probably the 2019 timeframe, there was a client that was brought in. My partner told me about that was a speedboat company. One of the things they wanted to try to do is to analyze their social media content against their competitors and see what it was that was causing their competitors' engagement to be so much higher than theirs was on social media. He hired a few data scientists and software engineers to be able to build out, to be able to extract all of the content, to be able to build some models, to be able to run the data through those models and see if they could come up with a predictive model that could help them analyze that market and see what were the engaging concepts that that company could adopt. That gave birth to this idea for Joot, which was, could we create a platform that would allow clients to come in who were active in social media and advertising, very active in producing web content and images, and produce what would be called like a playbook or some kind of insights that they could use to predict how engaging those images would be on their markets. This gave birth to Joot, to this idea. Could we build a system to do that? Could we make it so that it was scalable, so that we could build models that were small enough that we could train models using SageMaker and whatnot that would be small enough for us to be able to run within Lambda functions, and to be able to consolidate that in a way that was fast to develop, as low cost as possible for our clients, and as quick as possible. And so from the beginning, we decided to go with the serverless framework. I'm going to share my screen really quick just to kind of give you an overview, and so that you can see what it is that we built and how it's used. Okay. Here we go. So one of the things you do as a client when you sign up for Joot is you define, there are a number of markets that you can choose from. We have over 100 different markets that we've defined based on competing Instagram accounts. Those markets are divided into different industries, but one of the things you can do also is define your own market. So you can define a list of competitors that have active social media accounts. You can put those into a market you define. Our system will go in and then build, extract all of that data or pull all of that data down from those Instagram accounts, process all of the images through a pipeline that I'll show you in just a minute, how we did that, and then build a model in SageMaker to be able to use to predict what the scoring or how engaging images would be if they were used in that market. This is one of the features we have called Image Insights. What this does is give content curators and content creators the ability to see which type of images in that market are the most engaging for that audience. You click on these different categories here. This is what the model has come up with too. After scanning all of the thousands of images in a given market, it finds correlations or concepts that are common that are engaging amongst 2 to 3 images that it finds that have correlations. So creators can come through here and see these are the highly engaging concepts that I want to use when I go to create new content. But I can also see what the low performing concepts are. So I can come in and see, well, these are types of concepts I should avoid when I'm trying to create content as well, because these disengage my audience. One of the other features we have is the ability to upload images that you've probably unpublished, and those images will be ranked and scored against that custom model that you've built as well. So images that have green circles are ones that are likely to be more engaging, yellow are going to be average, and red would be ones that you would avoid trying to use. So we can actually predict what those image engagements are going to be using those models that we've created through the system. Okay, so if we go back and share, Stephen, if you don't mind sharing again the slide, I just want to give you kind of a brief kind of view into how we use serverless framework. This is just a small portion of what the kind of an architecture that we implemented for doing image processing. All of our users are managed using Cognito. Right out of the box, it was something that we easily incorporate into our serverless platform that we were using for doing all of user management, had all of the features that we needed to be able to do that for authentication. And we used Amplify as the library that we were using in our for our web app, and also Lambda to be able to coordinate that user authentication that would happen both on the Lambda side from the serverless point, from the web service point of view, and also from the web app. When a user comes into the system, you can see here they upload an image that was saved directly to S3 from the website. We then had triggers on the bucket that would go in and pull that image out, resize it, do some processing, pull metadata out of that image and store it into DynamoDB, where we would keep track of that user's image that was uploaded into their library, depending on the bucket that they uploaded it into. One of the things we wanted to use from the very beginning was rely heavily on event-driven architecture. And so Event Bridge was one of the services that we relied heavily on to be able to communicate between the different web services, microservices that we had defined in our serverless environment. We had, I would say, 5 or 6 different microservices that were partitioned out in ways that would handle customer data, pulling social media, handling images, doing the modeling work with SageMaker, billing, probably about a half different services that all communicated using the Event Bridge event handlers. So we would process an image, and one of the things we knew early on is that there were multiple things we wanted to pull out of an image. We wanted to figure out what the image quality was, what the salience was, what the color of the image was, classification. We used Clarify to be able to pass our image information, to be able to pull out tag information using models that they have, and several other processes. As you can see here, what we would do is that event would then place the information about the image to be processed into several different SQS queues, each attached with lambdas that would pull the image out and do their type of processing that they needed to. That all happened in parallel. We could have thousands of images being processed through the system at the same time, pushing that image data into those queues to be processed independently by those Lambda functions. We had to come up with ways to be able to coordinate determining when all of that processing for a given image was completed. Once we determined that the processing was completed, we would trigger another event. That would be picked up by another web service that would check to see if a model had been built for that market, for that particular customer, and then send it to a scoring queue for the image to be scored. That would then take the image and having gathered all of the image processing about the image, it would build a training file or training record to pass on to a model endpoint that had been built for that customer. So in SageMaker, one of the options that you have is to be able to host a multi-model endpoint or single model endpoints. We had single model endpoints for each model that was built for a customer. So when a customer built a model using SageMaker through our system, they had their own special endpoint to use to score for that market. So the image would be scored on that. It would throw another event saying that the image had been scored. That would be picked up by other services that could then take and rate the image, or to rebuild some market insights based on those image scoring. So this is just kind of a snapshot on how we kind of did our image processing pipeline. What that looked like is just a portion of the way we use serverless to be able to design and implement this type of image processing and scoring algorithms.
Chris,
sorry,
we got one question from Dorian, and his question is, did you consider step functions as an alternative to all the SQS queues?
So definitely, I would say probably halfway through architecting all of this and designing and building it, I took a serious look into step functions. I have no idea how I had kind of bypassed even being really aware of the power that step functions would have given me in controlling all of this kind of sequential processing of the images. If I look back now today, if I were to redesign this and re-architect, I definitely would have step functions. Would have saved me a lot of time having to try to track kind of the independent image processing that was taking place. So yes, definitely. I would very much consider using step functions to do what I was doing manually through tracking records in DynamoDB. One of the interesting things that happened too when we were doing this is, I'll bring this up because someone might run into this in the future too, like we did. All this image processing, we had a single record in DynamoDB for each image where we would store and append kind of the processing information from each service that was gathering that information for that image. And sometimes it was just small information, it wasn't a lot, but there would be dozens of pieces of information that we would need to update that image record with as it was being processed. And we come to find out that every time you update a record in DynamoDB, it rewrites the whole record. So as that record grows and gets larger, every time you write it, it takes up a lot of the resources that you have in DynamoDB for your number of writes that you can do per second. And so we would quickly run into throttling thresholds when we were processing multiple images, because we'd be writing a little tiny piece of data to an image record, but it would rewrite the whole thing. To get around that, what we did is just had an alternate DynamoDB table where we would store each of those bits of information separately as individual records. And then at the end of the image processing, combine all of those in a Lambda and then do one update to the image record. And that saved us a tremendous amount of resources that we were using DynamoDB to do that. So this event-driven kind of approach, one thing that we found very helpful was that for each event, each microservice that wanted to handle an event in Event Bridge, the easiest way for us to be able to kind of architect it in a way that kept it simple was to create handlers, right? And those handlers that you can see here are just very simple Lambdas. All they're responsible for within a microservice is to listen for an event, handle the event itself, and then perform whatever calls to other Lambda functions you may have in that microservice. So you may have more than one function on a microservice that wants to handle an event, but those separate event handlers came in very handily to be able to use that kind of approach. So why serverless? What were some of the key benefits that we found out? It was really from the very beginning, one of the questions that Stephen wanted me to address was like, well, what were the benefits between using serverless and something else? When we didn't start off Joot by trying something else and then deciding to go with serverless. This was a conscious decision from the very beginning. I knew for me, it was something that I had done a lot of research into, and we needed to develop fast. We needed to be able to get something up and running, and to be able to design our architecture with existing services that would just work. And so, some of these things it was the shortest path to architecture and development and deployment, because it was all in one. I could install it, set up a project, and from day one get something that was up and running. And we needed that. And there was, AWS, and in this case, we chose AWS just because it was something I was familiar with, but it was provided so many different services that were just turnkey services that we could use. For example, Cognito, like I mentioned, or Event Bridge, or Lambda, or DynamoDB. We knew from the very beginning we were going to use DynamoDB because of we could define our access patterns very clearly. And we knew that DynamoDB was designed to be able to accommodate that type of data access. If you had a very structured, well-defined data access pattern map for your applications you were developing. We wanted to be able to use multiple languages. One of my partners, who was the data scientist, was coding up all of the code for building the models and training them using Python on his own machine. My job was to take what he delivered to me in Python and then break that out into microservices that could be deployed to Lambda functions. And so half of our project, the project that I worked on myself, which was the API backend, was done in Node.js, but all of the development work for building the models and training them and using, specifically interfacing with SageMaker was done in Python. So having that flexibility to be able to use the same, serverless CLI with two different projects on the same machine using both Python and Node.js was fantastic. We wanted it to be scalable. We didn't know how much we would be growing, how quickly. We didn't want to have to depend on DevOps and worrying about whether or not we had enough resources available. So that was one of the #1 factors. And then free tier. We had that ability to start off in a free tier environment with some pretty generous monthly limits to be able to play around with things and not worry about costs getting so high for a startup company. So again, advantages, if I consider the alternatives, we had EC2 or ECS to choose from, which is really just replicating a dev environment out in the cloud, having to manage resources, having to worry about updating the machines, having to do all of the traditional things that so many of us have done before. I wanted to be able to eliminate that. And so the clear advantages were costs. We had that generous free tier limits. We knew that we could track and monitor the cost as time went on. And we could, ask AWS to extend those limits to certain things as we ran into them. If you've never used SageMaker with serverless before, AWS prevents you fortunately from getting out of control because it can be costly. Running those models, they do have different, pretty large sizes of instances, and it does take often hours to run and build models in SageMaker. So there are cost factors that you have to consider. Fortunately enough, AWS does limit how much you can use SageMaker from the beginning until you know that you're going to be using it to a full capacity. We didn't want to have any ops. We want to be able to define the architecture and code. We wanted developers to be able to understand what was going on and not just focus on code, but be able to understand how that code flowed through the services, what the services looked like, and how to configure them. And then, just overall we just needed to save time. And the way that you guys have designed and architected serverless is precisely for that reason. And for us, we were able to construct everything we needed within a 6-month period of time, and is wonderful. So anyways, if you guys have any questions, I know I've kind of reached my time limit here, but let me know. I'd be glad to answer anything for you. But also, kudos to the serverless team. Our experience at Joot was just, phenomenal, being able to use this to build this whole thing from scratch.
That's great, Chris. And so one question, and I apologize if you might have touched upon this earlier, was that it seemed like there were like a big variety or a big range of processes, both as far as like processing time as well as like resource requirements and compute requirements. Can you talk about kind of like the variety and range that was necessary, or
right?
that the different functions ran?
Yeah, most of those constraints were in Lambda. We found that we had some processes that needed to run longer than 15 minutes because they were crunching a lot of data. They were having to process a lot of data. We also had some of them that needed to use some pretty heavy modules to load them for doing machine learning type of tasks. And so we would reach that kind of 0.5 gigabyte limitation pretty quickly if we included too many of those modules in some of those Python lambdas that we were writing. So, some of those restrictions now, I know, Amazon just recently announced that they have a higher, I think it's 10 gigabytes of ephemeral disk space that you can have, along with your Lambda when you're using it. So that would have saved us so much effort of trying to what would you say, partition out some of those tasks that were that could have been done in a single Lambda and maybe divide those over the course of 2 or 3 Lambdas that call each other sequentially. So those were some of the constraints that we ran into. Some of them were memory limits as well, because we're using some libraries that when you're dealing with big data and you're having to use pandas libraries, for example, to be able to deal and handle records that have often tens of thousands or hundreds of thousands of columns in them, you can reach memory constraints pretty quickly. So there was a lot of monitoring taking place on the Lambdas for some of these. We realized that we could that we didn't need to process as much data to get as effective a model as we needed to for scoring. So, we could drop, columns that didn't have as high of an impact on the model production, things like that. So there was definitely, I would say, a month or 2 of time experimenting with really refining the way that we could use Lambda in a way that we could, effectively produce the kind of data that you can push the SageMaker. But it's the great thing is, AWS is constantly kind of pushing those back, giving you more resources to use in Lambda, which is fantastic. I think it would be great if we could run a Lambda for greater than 15 minutes. If that was, I know they do that on purposes so that you're not getting runaway Lambdas that you're being charged for, but if you could kind of maybe override that and be able to set kind of a time limit yourself would be a great feature.
Excellent. Okay. Well, thanks, Chris. Are there any last questions before we wrap up? Oh, I think we just saw a question pop up here. Okay, so I got a question from Dorian, and this is for us at Serverless. So is multi-cloud support advancing, and can a multi-cloud architecture improve the solution, or is it a distraction? So let me defer to Matthew and Gareth on this one.
Gareth, do you want to take this one?
Sure. We can. I mean, sure, we can both have an opinion on it, but it's so I understand the appeal of multi-cloud because you have the idea, like, if something's funky on AWS, you've got your Google or Azure or wherever else around to help with that. The unfortunate truth about multi-cloud support is that when you start trying to bake that into something like a framework, like the serverless framework, and you try to normalize that kind of support, you end up by only supporting the lowest common denominator of things. So, for example, you can't use some really nice nifty features of API Gateway because you're trying to normalize HTTP events across two different clouds. So you kind of get just the baseline of both, but neither of the good stuff out of either. The other point is as well that with the way a vendor like AWS has structured things, they generally have pretty good, and I know we've seen the outages at AWS, but they do have the ability for you to manage cross-regional stuff. So if you're worried about a region going down or AWS going down, AWS doesn't go down globally. I think that happened briefly once 5 years ago or something like that. But if you have that multi-region support, well, then you're generally pretty safe with those kinds of things. Again, the problem with multi-cloud is that you're again going to be trying to take the same stuff, deploying it in another environment, and kind of just mixing the bare minimum out of each instead of really getting the best out of both individually. So it's a very tricky one to answer, and we have worked on multi-cloud support for some customers in the past, and it is a very tricky situation to deal with, though. And the last point is that AWS is by far the big gorilla in the room. They have the most services, they have the most support, and so on. So if you're going to pick one, you're going to pick AWS, and they're big for a reason. They've got all the good stuff for a reason. They work really hard at it. Hope that helps.
Okay. Thanks, Gareth. And let's see. Kyle asked, will serverless support multi-region projects? Matthew, I saw that you typed your answer there, but you want to just recap it for the audience?
I did reply in line, but yes, this is something that we hear about regularly, multi-region support. And we don't have immediate plans like for the next month, but this is something that we definitely are aware of, and we're kind of bouncing ideas, basically. So it's on our minds.
Okay, great. Let's see. Okay, let's see if there's any more questions. I'm looking here in the chat. Cool. All right. Well, I think we're at just past the top of the hour. Hopefully this was informative and enjoyable for everyone here. If you have any questions or additional comments, shoot me an email. It's steve@serverless.com. You'll also all get a follow-up email after this call that has a link to the on-demand replay of this community call, as well as links to a lot of the resources that we talked about in the call as well. So thanks again for joining. Thanks, Chris, from Joot, for sharing your story. That was super interesting. And for everyone else out there, have a great Thursday. Thank you.
Thank you, Stephen.
All right. Thanks, everyone.
Bye, everyone.
Ciao.